Bismillahirrahmanirrahim. Good afternoon, everyone. Today our lecture will start from this question. Let's try to solve it together. Plot the curve between current at x-axis and voltage at y-axis at forward bias. We stay at the same topic. This topic is the diode. Here we're talking about forward bias. Let's try to calculate ln I by take two arbitrary amount of voltage and current, and after that draw the curve between x-axis, y-axis. We will start from Schottky diode. I equal I naught exponential constant diode V minus 1. At forward bias, we know V equal positively huge amount. That's mean here we can ignore it. Ignore I saturation current, and exponential alpha V will be exponential V, and the current equals saturation current exponential diode constant V, or exponential V, because V it's dominated. Let's take two arbitrary points. Like I said before, let's start with V1 and V2. V1 and V2, let me illustrate that. This V1 and this V2, V2 short bigger than V1, and that will face ln I1, ln I2 from this column, sorry. I1, ln I1, I2, ln I2, something like that. Here we have two different amounts, different points on y-axis, and two different amounts at x-axis. Here, all depend on this equation. I equals saturation current exponential diode constant V. Let's take ln to both sides. Ln I exponential ln saturation current exponential diode constant V between two brackets. And from the ln characteristic will be ln I naught plus ln exponential alpha V. Here that's mean ln I will equal ln saturation current plus alpha V exponential alpha V. Will be just alpha V, ln saturation current plus alpha V. This let's be the star equation, because let's be important to us. Maybe we will use it again. Ln I equal alpha V plus ln I naught at x-axis and y-axis. The curve will be linearly, but we will facing some difference between the theoretically and typically, like this diagram, because I will explain that later. But let's take a look here. Theoretically, we'll start from 0 point, but typically we'll start from 0 point. And theoretically, we'll start from some amount above the 0 point. Here, let's work on this equation, but when we're dealing with at low bias region, that means V will be very simple amount. From Schottky equation, I equal I naught exponential alpha V minus 1. I equal saturation current alpha V minus I naught. When V is very small, that's mean near from 0, and exponential 0 we know equal 1. That's mean here current, the total current will equal 0 at low bias region. When I equal 0, that's mean V equals 0, because from Ohm law, V equal IR, and I equal V divided on R. Now let's take ln to I equals 0. That's mean ln 0 equals 0, because that typically will start from 0 point, and after that at V1, this curve will be linearly and increases. like I said before, because that I started from 0 point. After that, starting to increases at after V1. Here at low voltage, partially from 0 point, theoretically from this amount above 0. Now let's talk about Adl diode. Like we said before, at Adl diode, the curve will be something like that. Liner at the at y-axis and another liner on the v-axis. Now we have two kinds of resistance: the statical resistance, or we can say DC resistance from Ohm law. Here at reverse bias, V equal minus V and I equal minus IR. That's mean here IR reverse current, and reverse resistance equal minus V divided on minus IR. But here at forward bias, the situation is different because V equal positively amount and I equal positively forward current. Forward resistance equal V divided on IF. Now we were talking about the second kind of resistance is dynamical, or we can say alternative current. Let's work on this example. Draw the curve between the dynamic resistance and voltage. Dynamic resistance will be at y-axis, voltage at x-axis. From Ohm's law, V equal IR, and dynamic resistance equal dV divided on dI. We can say like that, I divided on dI on dV. This very important equation will be to ask. Let's name it equation number 3. And come back to shortcut equation. I equal I naught exponential alpha V minus 1. Let's take derivation of V to both of these sides. dI on dV equal d on dV to between two brackets I naught exponential alpha V minus 1. Let to be like that. When I naught is constant, that means this side, this right side will be 0, because derivation to any constant thing equals 0. dI on dV equal d on dV I naught exponential alpha V. That's mean equal I naught will equal alpha I naught exponential alpha V. It's equation number 4. From equation number 3, 1 divided on dI on dV, we calculated the result about dI on dV equal alpha I naught exponential alpha V. RD will equal 1 on saturation current, diode constant exponential alpha V, like that. And because the dynamic resistance related with V, we can write it like that to be equation number 6. And we can write it by using another way. From the shortcut equation, we can say I plus I naught equal saturation current exponential alpha V will be, instead of that, will be, that's mean will be equation number 6 will be 1 divided on alpha I plus I naught. But we will depend on that to calculate, to kind of draw the curve, the diagram between RD on y-axis and V on x-axis by put 3 different amounts, minus infinity, 0, and infinity at last, to kind of draw this curve, like I said before. Now, at minus infinity will be very big value. After that, we will put it here to be the dynamic resistance at infinity, V equal very big value. That means will be at the top of the curve. When V equals 0, will equal constant. When V equal infinity, will be very small amount, because here very big amount and all of these are smaller than infinity. That means will be 1 divided over a huge number. When I put it above, will be very small number, near from 0, to be the curve like that. Dynamic resistance at minus infinity will start from above, at the middle when v equals 0, at the last are the dynamic resistance at infinity will be near from 0. Proof. Now let's calculate, let's try to calculate the rectification of dynamic resistance. Rectification, that means we will use this later. Dynamic rectification equal exponential alpha v. After that, calculate the unit of rectification, dynamic rectification. We know dynamic rectification equal dynamic resistance at reverse bias divided on dynamic resistance at forward bias. From Ohm law, R equal V divided on I, and from Schottky equation, I equal saturation current exponential alpha V minus 1. And dynamic resistance equal V on I naught exponential alpha V minus 1. Here, we will write instead of I Schottky equation to be equation number 2 like that. At reverse bias, we know V equal very huge amount, negatively amount, equal minus V. We can say here, dynamic resistance at reverse bias equal minus V divided on Schottky equation, I know exponential alpha V minus 1, to be at last, at the end, like that. At forward bias equal positively amount, to be positively amount on saturation current exponential alpha V minus 1. Let's calculate 3 on 4 to be like that. Minus 1 divided on exponential alpha V minus 1 dot to be here exponential alpha V minus 1 on minus exponential minus alpha V minus 1. Let's this side, the last result to this amount equal 1, and try to do some simplified to this equation to make it be easier. Will be exponential alpha V between two brackets exponential diode constant V minus 1 on minus exponential alpha V, something like that. Let's work on this side to be at last all these math trick to be equal exponential alpha or diode constant V. I put this amount inside this bracket. After that, exponential 0 equal 1 to be like that. Minus 1 plus exponential V, or we can say exponential alpha V minus 1. We can delete all of these to be at last, we will dealing with this element exponential alpha V. That's mean the rectification of dynamic equal exponential alpha V. That's mean we prove it. Now let's work on the unit. Like we know, rectification of dynamic resistance equal reverse resistance with Ohm divided on forward resistance with Ohm. That's mean this rectification dynamic dimensionless. Forget diode. Let me write this. Rectification dynamic for good diode equal exponential 7 to exponential 9. Now at non-ideal, Calculate the dynamic current or prove the dynamic current to non-ideal equals saturation current between two bracket exponential alpha v minus 1. Short-key equation. Prove the short-key equation, or we can say by using another word, calculate the dynamic current at non-ideal. From Kirchhoff voltage, V total equal the other voltage, V1 plus V2 plus blah, blah, blah. Here, we're dealing with two kinds of voltage, dynamic voltage and RC voltage. That means V total equal V dynamic plus V series resistance voltage. For Ohm's law, V equal IR, and VRC we know equals saturation current dot RS. That means series resistance dot saturation current. But what about dynamic voltage resistance? From short equation, I equal I naught exponential alpha V minus 1. Here V equal VD, that means dynamic voltage. This is wrong. This VD, sorry, ID. Here, we will do some modification on the short equation when I equal ID dynamic current and V will equal VD. That means here ID, not saturation current, not I0 or I naught, ID equals saturation current exponential alpha VD minus 1. That's mean here ID divided on I naught equal exponential alpha VD minus 1, exponential alpha VD equal ID divided on I naught plus 1. Exponential to both sides to be alpha VD equal ln ID on I naught plus 1. That's mean here VD equal 1 divided on alpha ln ID divided on I naught plus 1. We will use this equation the next lecture too much, because this equation is very important. The dynamic voltage equal 1 divided on diode constant ln dynamic current on saturation current plus 1. Now let's work on V total. Like I said before, V total equal VD plus VRS. That's mean equation number 3 will be here plus VRC from Ohm law. We can write it like that. Now V total minus VRC equal 1 on diode constant ln ID on I naught plus 1. To be like that, we will put the diode constant here and take exponential to the both sides. You can delete ln here at the right side to be exponential alpha VT minus I naught RS equal ID on I naught plus 1. At last, that's mean here ID on saturation current equal exponential alpha VT minus IRS minus 1, and ID equal I naught exponential alpha V T minus IRS minus 1 between two brackets dot saturation current. And add all that at non-ideal diode, but when dealing with ideal diode, we can use the same equation, but we must focus, we must note it, the important condition, this condition at ideal constant is we don't have series resistance equals 0. That means we will come back again to short equation. Thank you so much. Our lecture is done. Thank you about your patience, your listening. Have a good day.